Dear colleagues, it's a great pleasure to present you my work on machine learning for rational design and reliable prediction of activity of gene regulatory regions. Let's start from the description of the data we are going to work with. In this work, we worked with two data sets from massively parallel reporter assays. The first data set is collected for East promoter sequences and were used in DREAM 2022 competition. The second data set was collected in a paper by Agarwal et al. 2023, and it measures the activity of human regulatory element expression. To work with these sequences, we use convolutional neural network, and to make data well suited for it, we one-hot our sequences, and also we add two additional channels. First channel is singleton channel, and it tells that the quality of object we passed to the data set is good or bad, and it allows model to account differently for high quality objects and low quality objects. Also, we use a reverse complement channel to tell model the orientation of sequence we passed to it, as the activity of regulatory sequence can highly depend on its orientation. We used EfficientNet v2 model as the basis for our architecture. We applied a few modifications to this model. For example, we replaced residual add blocks with residual concat blocks, and it allows out to use fewer number of parameters. And also we used one cycle learning rate to train our model, and it results in superconvergence, increasing the final model quality. During the competition, we showed amazing performance, greatly surpassing all other solutions. And actually, according to for the post-competition analysis, it wasn't possible to come up with a better architecture or other learning designs. After that, we decided to apply our model for human data from the set mentioned previously. And surprisingly, we found that our model trained from scratch outperforms models pre-trained on encoded data such as CA and Informer, and on 2 data sets out of 3. And actually, on the third data set, our model shows quite relatively good performance, and this data set is of bad quality in general, and many further works, they tend to exclude this data set from the analysis. Our next step was to find out if LegNet learns regulatory grammar, and actually we compare attribution scores gathered by in silico saturation mutagenesis with in vitro measurements. We observed that actually, yes, our model is really good at detecting transcription factor binding signs in this sequence, and in general profiles look quite similar. Next, we applied our model to the third data set, Imperi, also on Drosophila regulatory regions. And again, our model showed better performance than existing methods, but actually modifications of our model done by our colleagues increased the quality of model significantly. After that, we decided to check if our model can predict allele-specific events in human genome. We used data from our collaborators, And actually, yes, we find out that our model surpasses baseline model in all cell lines available, and actually it surpasses by a huge margin. Next, we tried to evaluate our model on homogeneous accessibility prediction task. It is well known that current state of the art in this area is home BPNet presented by Anshul Kundaje. But actually we can observe that our model performs on par with this model. Moreover, if we modify our model, as our collaborators did, model performs better than home BPNet. And in both cases, these models, they use much fewer number of parameters than home BPNet. So they are efficient both in terms of quality and parameters. The next step of our research was to test if we can use our model to generate new sequences with specified promoter activity. And we decided to use diffusion approach to do that. It was really surprising that actually yes, if with proper training and noise addition scheme, there we gradually mutate our sequence and ask our model to restore mutated original sequence given mutated sequence and original expression. Actually, if we use such a scheme, we can use our model to generate high quality promoters with desired expression, and the correlation between predicted expression and expression we asked model to come up with is really high. So in general, we have shown that we are really successful in this at this task. Unfortunately, now I can't disclose any details on further validation of this approach, but actually they are quite promising. And in case of NA sequence design, it turns out that LegNet diffusion approach works really well and outperform other non-machine learning based approaches. Thank you for your attention.